Next topic is orthogonal trajectories. The family of curves which is orthogonal to every member of given family of curves is called orthogonal trajectories of given family of curves. That is the given family of curves uh, such that every curves is orthogonal to every member of family of orthogonal curves. The family of curves, that is every member of the family of curves, is orthogonal to every member of given family of curves. Then this family of curves is called orthogonal trajectories of the given family of curves. For example, the example is find orthogonal trajectories of y is equal to mx. So y is equal to mx is what? Is the equation of straight lines passing through origin. So if we change, if we take m as 1, then y is equal to x is what? Is the line passing through origin which divides the first quadrant and third quadrant into equal parts, or the line which makes an angle 45 degree with x axis as well as y axis. So y is equal to mx, then y is equal to 2x, y is equal to 3x, y is equal to minus x is the line passing through the second and third quadrant, second and fourth quadrant, which divides the second and fourth quadrant into equal parts. That is y is equal to minus x. All these lines are y is equal to mx, y is equal to mx, the lines passing through origin. So, and what are the, this is the given family of curves. That is where given what? The family of straight lines passing through origin. And we have to find the orthogonal trajectories of this family of curves or family of straight lines. So what is the procedure? Y is equal to mx is the given equation. We differentiate with respect to x. So m is the parameter or arbitrary constant, and there is only one constant, so differentiate with respect to one's uh, first order derivative. Dy by dx is equal to m, and then delete or eliminate m from equation 1 and 2. So substitute m as dy by dx in equation 1. So what do we have? Y is equal to x dy by dx, and then replace dy by dx by minus dx by dy. So what we have? We have the equation of, this is the equation of orthogonal trajectories, and that is y is equal to minus x dx by dy. And solve this equation. So this is the equation, differential equation in variable separable form. Separate the variables. What we have? Y dy is equal to minus x dx after separating the variables, and then integrate both sides. We have the answer y square by 2. Integration of y is what? Y square by 2 is equal to minus x square by 2 plus, suppose c1 as the constant of integration. Then dividing by 2, we have y square is equal to x minus x square plus c1 by c1 into 2. And suppose that c1 into 2 is new constant c, and therefore we have the equation x square plus y square is equal to c. And this is the equation of circle having center 0 0, that is center is origin. And so how we denote this? And c, if we change the c, if we suppose c is 4, value of c, this constant is 4, then it is the equation of circle passing through circle having center origin and radius 2. So what is the family of this x square plus y square is equal to c? Is the family of circles with center 0 0 and of different radius. That is suppose 1 is the radius, 2 is the radius. So in this figure, this these circles is the family of these curves. These x square plus y square is equal to c. So this is what this family, this x square plus y square is equal to c, is what is the orthogonal trajectories of the family of y is equal to mx. That is each member of this family, orthogonal trajectories, each member of this family is what? Is orthogonal to each member of the given family, and therefore this is the x square plus y square is equal to c is the orthogonal trajectories of the given family y is equal to mx. That is each member of this family is orthogonal to each member of the given family, and therefore this is the, that is because if you observe this circle and these straight lines, if you draw the perpendicular to this circle at this point, then it is perpendicular to this straight line y is equal to mx. Every member. So next example is find the orthogonal trajectories of family of curves x square by 2 plus y square is equal to c, which passes through 1 1. So first find the general family of orthogonal trajectories and then substitute x and y as 1 1 and find the value of c. So we have the answer y is equal to x square c square, that is actually y is equal to x square is the equation of parabola, and it is orthogonal trajectories of the given family of curves. That is differentiate this given equation, find first order derivative and eliminate arbitrary constant c from the equation number 1 and that equation number 2, and then replace dy by dx by minus dx by dy and find the and its solution. We get this answer y is equal to c square x square c square, and that is c is 1. If you substitute c as 1, y is equal to x square is the particular member which is orthogonal to this given family. So next is theorem, find the orthogonal trajectories of system of curves gxyz is equal to c on the surface fxyz is equal to c. This is the three variable function. These are the problems for two variable functions. Now this is the theorem for three variable functions, that is gxyz is equal to c is the equation of curve and fxyz is equal to 0 is the equation of surface. So denote fxyz is equal to 0 by using by number equation numbering 1 and gxyz is equal to c as number 2. So the equation number 1 is represent equation of surface and equation 2 represent equation of curves, family of curves. Let p x y z be any point on the curve, and then dx dy dz be the direction ratios of the tangent line to the curves which cuts the given family of curves orthogonally at point p x y z. So what are the dx dy dz? These are the direction ratios of the tangent line to the curves which cuts the given family of curves orthogonally. That is, these are the tangent lines to the orthogonal trajectories. That is, the curves which cuts the given family of curves orthogonally means orthogonal trajectories. Dx, dy, dz are the what? Direction ratios of tangent line or tangent to the orthogonal trajectories at the point p, x, y, z. So from 1 and 2 we get and complete derivative, that is df is 0 and dg is 0, the complete derivative, and the df is what, fx dx plus fy dy plus fj dz is equal to 0. Suppose it is third equation, and then dg is equal to 0, that is the complete derivative of this function gxyz is what, gx means what, g suffix x means dabba g by dabba x dx, gy means dabba f by dabba g by dabba y dy plus dz, gz means dabba g by dabba z, dz is equal to 0, equation number 4. Then solving equation 3 and 4 by Cramer's rule, we have dx divided by determinant fy fz gy gz minus dy divided by fx determinant fx fz gx gz and dz divided by the determinant fx fy gx gy, and then this determinant is the Jacobian dabba fg dabba yz. This determinant fy fz gy gz is what, Jacobian dabba fg capital F capital G dabba yz, and this by right here dy, and if you take absorb this minus sign in this determinant, then we have that is interchange any two rows or any two columns. So if we interchange the columns, then we have it is determinant dy divided by determinant fz fx gz gx, and it is a Jacobian dabba fg dabba zx. That is that is this sign negative. Because of this sign negative, interchange the rows or interchange the columns, then we have dy divided by determinant fz fx gz gx, and it is Jacobian dabba fg dabba zx, and dz divided by this is the Jacobian dabba fg dabba xy, and we denote these quantities by capital Q capital R capital P, capital Q, and capital R. And then we have the equation dx by P, dy by Q, dz by. And we know that these PQ are what? These are the direction ratios of the tangent line to the curve at point P, X, Y, Z. So if F and G are the given two surfaces, then what is the PQR? PQR are the what? Are the direction ratios of normal to tangent to the curves. So P is what? Dabba FG, dabba YZ. Q is dabba FG, dabba ZX, and R is what? Dabba FG, dabba XY. So PQR are the what? Direction ratios of tangent line to the curves. So here this PQ are what? These are the direction ratios of PQ are the direction ratios of tangent line to the curve at the point PXYZ. And by the condition of orthogonality, what we have? P dx plus Q dy plus R dz is equal to 0. So this dx, dy, dz are the direction ratios of the tangent line to the orthogonal trajectories or the curves which cuts the given family of curves orthogonally at the point P, X, Y, Z. Means this tangent line, that is the tangent line to the family of orthogonal trajectories, and these PQ are the direction ratios of the tangent line to the curve, and these and therefore these two tangents are perpendicular to each other. And so by the condition of orthogonality, that is, if the two vectors are orthogonal, then their dot product is 0. So the dot product of this vector dx, dy, dz, and another vector is what? PQR, or Pi plus QR j plus Rk is what? P dx plus Q dy plus R dz is equal to 0. This is the dot product of these two vectors. And so by using condition of perpendicularity or orthogonality, we have this. And we know that this fx, fy, fz are the direction ratios of normal to the surface at the point P, X, Y, Z. So this fx, actually this fx, fy, fz is what? Is del f. What is del f? What is the geometrical meaning of grad phi, grad f? The grad f is what? Is the normal vector to the surface. So what is del f? Del capital F is dabba f by dabba x, or that is fxi plus fyj plus fzk. And what is the meaning of del f? Del f is normal to the surface. And so the coefficient of ijk means fx, fy, fz. Fx means dabba f by dabba x, fy means dabba f by dabba y, fz means dabba f by dabba z. These are the direction ratios of what? Normal to the surface at the point P, X, Y, Z. So this is actually the geometrical meaning of del f or grad f. So what is grad f? The grad f is, or grad phi is what? What is the definition of grad phi or del phi? So grad phi is dabba phi by dabba xi, dabba phi by dabba yj, dabba phi by dabba zk. And the grad phi, the geometrical meaning of gradient of phi is what? This is grad phi is dabba phi by dabba xi, dabba phi by dabba yj, dabba phi by dabba zk. And what is the geometrical meaning of grad phi? This grad phi is the tangent to the is the normal to the surface, and means the coefficient of ijk means dabba phi by dabba x, dabba phi by dabba y, dabba phi by dabba z are the direction ratios of normal to the surface phi. So here, what is del f? Del capital F is dabba f by dabba xi, dabba f by dabba yj, and dabba f by dabba zk. That is fxi plus fyj plus fzk, and this coefficient of ijk, that is fx, fy, fz, are the direction ratios of normal to the surface at the point this. And therefore we have fx dx plus fy dy plus fz dz is equal to 0 by using the condition of perpendicularity, orthogonality. And p dx plus q dy plus r dz is equal to 0. This is equation number 5. Suppose now it is equation number 8, and this is equation number 6. Then this is equation number 7, and this is equation number 6. Then solve the 6 and 7 by Cramer's rule. We have dx divided by fy fz qr minus dy divided by fx fz pr and dz divided by fx fy pq. And after solving this, we denote this determinant by suppose p dash, this is q dash, and this is r dash. Actually, what is q dash? Q dash is what, after accepting sign, that is interchange the columns, right? The second column as first column and first column as second column, then it is q dash. Suppose it is q dash, and this is r dash. Then solve this equation number 8 and its solution with the equation number 1 forms or gives the orthogonal trajectory, required orthogonal trajectory. That is solving equation number 8 and its solution with the equation number 1 gives the required orthogonal trajectory. So this is the procedure to find the orthogonal trajectory. So examples are important as far as exam concern. So these examples of orthogonal trajectories are important. Find the orthogonal trajectories on the surface x square plus y square plus z square is equal to a square of its intersection with the parabolas, that is curves xy is equal to cz, where cz is the parameter. So we do not by capital F by the equation of surface. So equation of surface is what? X square plus y square plus z square minus a square is equal to 0. So this is the equation of surface. So denote the equation of surface by notation capital F, and denote the equation of curve by capital G. So capital G is what? xy minus cz. So these are the equation number 1 and 2. Then we have df is equal to 0, dg is equal to 0. That is fx dx plus fy dy plus fz dz is equal to 0. That is 2x. Fx means the derivative of f with respect to x is what? 2x. Derivative of y square and z square and minus a square are 0. Then fy is the derivative with respect to y is 2y dy plus 2z dz fz. That is, if we divide by 2, then we have x dx plus y dy plus z dz is equal to 0, equation number 3. Similarly, dg is equal to 0 means gx dx plus gy dy plus gz dz is equal to 0. So what is gx? The derivative of this quantity with respect to x is y plus gy means the derivative of this quantity with respect to y is x dy, and the derivative of this quantity with respect to z is minus c dz is equal to 0. So this is equation number 4, and then all the equation 3 and 4 by Cramer's rule. We have dx divided by fx fz. Write directly this dx divided by yz x minus c, yz x minus c. Then dy divided by minus dy divided by xz and y minus c, xz y minus c, and dz divided by x y and yx. And then value of these determinants are what? Minus cy minus hz. Then determinant value of this determinant is what? Minus xc minus yz, and the value of this determinant is x square minus y square. Then after effect of negative sign, we have dy divided by cx plus yz, and this is of the form dx by p, dy by q, dz by r. So what are pqr? Pqr this. P is what? Minus cy minus hz. Q is cx plus yz, and r is x square minus y square. So these pqr are what? Direction ratios of tangent to the curve at this point. And as fx fy fz be the direction ratios of normal to the surface, we have fx dx plus fy dy plus fz dz is equal to 0. That is 2x dx. Fx is what? 2x. Fy is 2y. Fz is 2z. And therefore x dx plus y dy plus z dz is equal to 0. This is equation number suppose 5. And px dx plus p dx plus q dy plus r dz is equal to 0, because by using the condition of orthogonality. We have this. And what is p? P is this. P is minus cy minus hz dx, right here dx, plus, right, the value of q is cx plus zy dy plus r is x square minus y square dz is equal to 0. Suppose this is equation number 6. Then solving equation number 5 and 6 by Cramer's rule. We have dx divided by y dx divided by yz, and the second row is what? Cx plus zy and x square minus y square. Similarly, minus dy divided by xz and minus cy minus hz x square minus y square, and dz divided by xy and what? Minus cy minus xz and cx plus zy. Then solve these determinants. We have this and these answers. So we have this equation: dx divided by this, dy divided by this, and dz divided by this. And we have to solve this equation. And this equation is of the form dx by p, dy by q, dz by r. And we know there are two basic methods to solve this type equation, simultaneous equation. That is either consider any two ratios in which the third variable is absent, or find the multiplier such that x into p plus y into q plus z into r is equal to 0. So here choose the multipliers x, y, z, and therefore each ratio is equal to x dx plus y dy plus z dz divided by multiply this quantity by x plus multiply this quantity by y plus multiply this quantity by z. We have the answer 0, and therefore x dx plus y dy plus z dz is equal to 0. Integrating, we have x square by 2 plus y square by 2 plus z square by 2 is equal to, suppose c1 is the constant of integration, then multiply by 2 and write 2 c1 as c. We have this x square plus y square plus z square is equal to c. And this equation number, suppose this is equation number 7, and then 1 and 7 gives the orthogonal trajectory, gives the required orthogonal trajectory. So this is the procedure to solve the problems orthogonal trajectory. That is, first find the df and dg and equate with 0, solve by Cramer's rule, and suppose and then find capital P, capital Q, and capital R. That is the direction ratios of tangent line. And then by condition of orthogonality, we have P dx plus Q dy plus R dz is equal to 0. And solve this equation with this equation: fx dx plus fy dy plus fz dz is equal to 0 by Cramer's rule. And obtain the solution of this equation, that dx by p dash plus is equal to dy by q dash dz by r dash. And find only one solution of this equation by using either first method or second method, and then its solution with the equation number 1. That is, what is the equation number 1? 1 is the equation of surface. So the solution of that equation, and equation number 1, that is the solution of, that is the equation of surface given in the problem, gives the orthogonal trajectory. So the next problem we'll see in the next lecture.